In this video, we're going to talk about part 2 of Module 1, Topic 1, Lesson 4. So again, by the end of part 1 and part 2, we should be able to answer these 4 essential questions. How does adding or subtracting a number to the outside of the function transform it? How does multiplying a function by a number on the outside transform it? How does adding or subtracting a number to the inside of a function transform it? And how does multiplying the inside of a function transform it? So we have already answered the first 2 essential questions in part 1. So if you need to go back to watch that, go back and watch that. Today we're going to focus on the last 2 questions. So we are going to go to the back of the second page where we find activity 4.3. And we are going to go ahead and graph these using our technology. So mine does have a typo, but yours should be fixed. Okay, so again, you're going to type these into the equation or into the calculator, pull up the table to plot some points. When you graph these, you need to make sure that this is going inside the absolute value bars, and then that is a minus sign. So for me, I will plug in some values just to get used to it. So I'm going to start by plugging in 0 this time. I'm going to switch it up a little bit because I know what the graph is going to look like. So I'm going to plug in 0, 1, 2, 3, and 4. So when I plug in 0, 0 minus 2 is 0. Absolute value of negative 2 is 2. I said that completely wrong. 0 minus 2 is negative 2. The absolute value of negative 2 is positive 2. There we go. 1 minus 2 is negative 1. The absolute value of negative 1 is positive 1. 2 minus 2 is 0. 0, absolute value of 0, is 0. 3 minus 2 is 1. 1, the absolute value of 1 is 1. And 4 minus 2 is 2. The absolute value of 2 is 2. So I'm going to plot these points. 0, 2, 1, 1, 2, 0, 3, 1, and 4, 2. And we're going to connect the dots. Okay. If we look at this from the parent function, notice it looks like it's been moved to the left, or sorry, to the right 2. So right 2 units. Okay. Notice that the range is the same. It didn't change. The range is still y is greater than or equal to 0. Okay, looking at the next one, we're going to plot, and this time I'm going to use some different points. Again, why? Because I know the points that I need to graph what I want it to graph. So this time we're going to start at negative 4 and work our way to 0. So negative 4 plus 2 is negative 2. Absolute value of negative 2 is 2. Negative 3 plus 2 is negative 1. Absolute value of negative 1 is 1. Negative 2 plus 2 is 0. Absolute value of 0 is 0. Negative 1 plus 2 is 1. Absolute value of 1 is 1. And 0 plus 2 is 2. Absolute value of 2 is 2. So we're going to go ahead and plot these. Negative 4, 1. Or sorry, negative 4, 2. Negative 3, 1. 2, 0. Negative 2, 0. Negative 1, 1. And 0, 2. So I'm going to go ahead and connect the dots. Make sure that when you connect them, you place arrows, because this does keep going. So this time from the parent function, this has gone to the left 2 units. So since it's gone to the left 2, it's just a different type of transformation. The range for this is the same. It did not change. Y is greater than or equal to 0. So now I want to pay attention to where is the number and why did it cause it to do what it did. So the number now is on the inside. So we need to know inside affects the graph horizontally. Outside affects the graph vertically. Now, the general equation, okay, for problems like these are x minus c, okay? In this case, For m of x, we plugged in a c value of 2, which is why it's x minus 2, and it's going to the right. But on n of x, our c value is not 2. It is negative 2. And that's why it went to the left. So how does it turn into a positive? Well, remember, the x minus, and we plug in a negative 2, okay, causes our equation, because of that double negative, to turn into what looks like a positive. So when you are looking at these equations, you have to think of opposite. This looks like a minus 2, but it's really going in the positive direction. This looks like a positive 2, but it's really going in the negative direction. Okay? And so what this is called, or what we say, is that a function t of x in the form of t of x equals f of x minus c is a horizontal translation of the function where the values of the absolute value of c describes the number of units the graph of f of x is translated to the right or left, or you can say left or right. And here's the important part. If c is greater than 0, then the graph is translated to the right. And if c is less than 0, then the graph is translated to the left, which is what I just talked about here, our c value being greater than 0 or less than 0. Okay, so what we're going to do is we're going to write the functions m of x and n of x in terms of the basic function and describe how the changing c value in the function m of x and n of x horizontally translate the function. We've already done that second part up above, so we're just going to rewrite it here. So we have m of x, that is equal to g of x minus 2, and then we had n of x, which is equal to g of x plus 2. Great, so again, when we have the minus 2, we're going to the right. When we have the plus 2, we're going to the left. So again, moves opposite of what it looks like. Oops. There we go, if that's helpful. So now with the coordinate notation, when you're doing coordinate notation, you do need to know what that c value is. So is that c value a positive 2? Is that c value a negative 2? Because that's going to affect it. Since we are moving the graph left and right, this time we are affecting the y, or the x value. So now we're going to have plus c here, and our y value is going to be left alone. Okay, our y value will be left alone. Okay, so now moving on to our last transformation. Our last transformation is when we are multiplying by a number on the inside. So on this first one, I'm not going to make a table this time. Okay, actually, yep, I'm going to make a table this time. Okay, again, you can graph this in the calculator, okay, if you want to, and you can pull up the table. These are the same values you should be getting in the table, but knowing how to do it by hand is not going to hurt you. So negative 2. 2 times negative 2 is negative 4. The absolute value of negative 4 is 4. Negative 1. 2 times negative 1 is negative 2. The absolute value of negative 2 is 2. 0. 2 times 0 is 0. The absolute value of 0 is 0. When you plug in 1, 2 times 1 is 1. 2 times 1 is 2, and the absolute value of 2 is 2. And when you plug in 2, 2 times 2 is 4, the absolute value of 4 is 4. So when we plot these points, we have negative 2, 4, negative 1, 2, 0, 0, 1, 2, and 2, 4. So our graph looks something like this. Now, what I need you to know is that this looks very similar to the vertical stretch, but the number is in a different location, and when it's on the inside, it affects the graph horizontally. So what I need you to think about is that we are horizontally compressing this graph. We are pushing it towards the y-axis, which is making it more narrow. So what this is a horizontal compression. And this is where it gets trippy, by a factor of 1/2. By 1/2. So your B value is 2, but you talk about it as 1/2. Okay? Now, looking at the next one. Okay, we need a table. You can graph it in the calculator. You can pull up the table. I'm going to pick values that I know work. So, 1/2 times -4 is -2. Absolute value of -2 is 2. 1/2 times -2 is -1. Absolute value of -1 is 1. 1/2 times 0 is 0. Absolute value of 0 is 0. 1/2 times 2 is 1. Absolute value of 1 is 1. 1/2 times 4 is 2. Absolute value of 2 is 2. So we plot these points. 4, 2, 2, 1, 0, 0, 2, 1, and 4, 2. Sorry, the other side should have been negatives. Okay. So now, what this looks like is it looks very similar to a vertical compression. But this time, I want you to think about pulling this graph horizontally. When you pull it horizontally, it's going to get more wide. So this is known as a horizontal stretch by a factor of, and this time our B value is 1/2, but it's a stretch factor of 2. Okay. And then the last one, okay, when we pick some points, oops, let's just do -2 to +2. So when I plug in -2, the -2 is a +2, absolute value of 2 is 2. A -1 is 1, absolute value of 1 is 1. 0 is just going to be 0. A negative times 1 is -1, but the absolute value of -1 is 1. And negative times 2 is a -2, but absolute value is 2. So we plot these points. Okay. Now, this looks just like the parent function, and that is not always necessarily the case. It really just depends on what you're reflecting it over, but this particular one was reflected over the y-axis. And the y-axis is a x equals 0 equation. Okay, now one thing I didn't say is what is the range of all of these, and the range for all of these is y is greater than or equal to 0, because they all have a minimum value of 0, which is the y value. Okay, so what this tells us is that the function, recall the function t of x in the form of f of b times x is a horizontal dilation of the function f of x. The b value describes the horizontal dilation of the graph of the original function. So when your b value is greater than 1 in the equation, that was our very first example, that means that you have a horizontal compression by 1 over b. You turn it into a fraction. When b is less than 0, so that means a negative number, negative b, then that is when you reflect over the y-axis, which is x equals 0, and if it were a negative 2, it would be a compression. If it was a negative 1/2, it would be a stretch. So, and it has a horizontal dilation. Remember, dilation covers stretches and compressions. Okay. Now, when the b value is, and again, this right here was a typo, when the b value is between 0 and 1, this is when we have a horizontal stretch. By 1 over b. So what that means is if it's a 1/2, it will become a 2. It's just flipping the fraction. Okay? And so each point on the xy graph becomes what on f of x? So when you have this transformation, okay, what's going to happen is you are going to multiply that a value or that x value by 1 over b, and your y value is going to stay the same. Okay? And so then the last part, when a function is transformed by changing the a or d values, okay, these changes are said to occur outside the function. These values affect the output to the y. They affect the output of the function, which is the y values. So that is talking about the a and d. Those are outside the parentheses, outside the absolute values. They affect the y values. When the b or c values are changed, this is said to change the argument of the function. A change to the argument of the function is said to happen inside the function. These values affect the input, which is our x. So that is the b and the c. That is inside the parentheses, inside the absolute value bars. They are affecting the x because they are directly touching the x. Okay? So what I would like you to do is I would like you to try these right here. See if you can write it in function form and equation form, and then go to Google Classroom to check your answers. If you have any questions, please go ahead and write them down so you remember to ask me. And then by now, you should be able to answer all 4 of the essential questions in a paragraph.